Hey guys, welcome to the channel. We're going to be solving question 9 from the second chapter of the Johnston textbook, Engineering Mechanics. And we have a telephone cable that is clamped at A to the pole AB. We know that the tension in the right-hand portion of the cable is 1,000 pounds. So we know our T2 in here is 1,000 pounds. And we need to determine by trigonometry, A, the required tension, T1 in the left portion, and also we know that the resultant of these two forces has to be vertical, so it will be a downward force, no x component, or I should say no horizontal component. And in the B part, we need to find the corresponding magnitude of the R. So we're going to use the triangle rule in order to find the resultant, and for that, we're going to draw a line parallel to T2, same magnitude, in order to cross our vertical point. So this is basically our T2, and question is asking to have our resultant, which is the vector that connects the beginning of first vector to the tail of the second vector, R. And now from the triangle rule, we know that R would be the resultant. So we're going to look at this triangle that I'm highlighting in yellow. And as long as we have the angles, if we use the law of sines, we should be able to find all the unknowns that we have in here, which is the T1 and R. So let's see what the law of sines says. So basically we have this side, which we know is T1 over sine of the angle in front of it, like this angle, we can call it alpha. Sine of alpha is equal to the other side, let's go with T2 over the angle in front of it. We can call this one beta, so sine of beta. And this will be equal to the other side, which is R, over the angle in front of it. We can call this gamma. So sine of gamma. From the question, we know our T2 is 1,000 pounds. If we can figure out the angles that we have in this question, we should be good to go. And let's see if we can find this angle. So finding the beta is pretty easy because we have this right angle. This part is 15. So if we want to find beta, we basically have 90 minus 15 degrees, which is 75 degrees. So we found one. If we can figure out another one, we should be able to find the last one because we know the sum of all these angles in triangle has to be 180 degrees. So we should be fine if we can manage to find another one. And if you look at the gamma in here, it's actually easy to find because if we do a parallel line to our horizontal, this angle is equal to this one. So this part is 15 degrees. And the other part is actually what we have in here, 25. So 15 degrees plus 25 degrees is going to give us the gamma, which is 40. Now alpha is pretty easy. You have 180 minus 75 minus 40 degrees. So alpha in here would be 180 minus 115 or 65 degrees. Now that we have this, we should be able to find all the unknowns that we have in here. So let's start with T1. So we have T1 over sine of alpha 65 degrees is equal to 1000 over sine of beta 75. So we can find T1 1000 sine of 65 over sine of 75. So let's see what we get for T1 1000 times sine of 65 over sine of 75. So our T1 would be 938.28 pounds. That's the first unknown, and what we did in here is basically they cross multiplying these two. And for finding the R, we can pick these two. So 1000 over sine of beta, which was 75 degrees, is equal to R the second unknown that we have over sine of gamma, which is 40 degrees. So our R in here, again, if we cross multiply these, we have 1000 times sine of 40 is equal to R times sine of 75. So our R would be 1000 times sine of 40 degrees over sine of 70. So let's calculate R in here, again, 1000 times sine of 40 divided by sine of 75. That's going to give us 665.46 pounds, which would be the final answer for this question. Hope you guys find this one helpful. Let me know if you have any specific problem from the 3 textbooks that we're covering in this channel. Feel free to check out the playlist and let me know if you want me to cover that specific problem in the next videos. And you guys take care. I'll see you in the next one.